Hello?
Good evening, Robert. This is Michael Vera with Late Night in the Midlands. How are you?
I'm just fine, Michael. You can call me Bob on the air.
All right.
In conversation, by the way.
That's great. I was just going to ask you if you'd rather I call you Robert or Bob. So, all right.
Well, when you introduce me, talk about things in print, Robert Zimmerman, but in conversation, Bob is fine.
All right. Well, thank you for pointing that out. And Bob, I welcome you to the show, and I'm looking really forward to kind of picking your brain about some of the things that are going on and what you know about them. So,
all right. Do you have a plan of action? We got a long interview, and what you want to talk about?
Yes, I do, and we're actually live now. So.
Oh, we are. Okay.
We are. So I'm ready to go, and. Well, I guess first, maybe a little background and what led your deep interest into space and beyond.
Well, all right. Well, first of all, I grew up in the 60s, and so, I was seeped in the original space race and the first efforts to get off of the surface of the Earth. And so that excited me as a kid. But as I matured, my interest matured to a wider concept of just interest in exploration in general. And that involves science, because a scientist, what they're really doing, if you understand what scientific method really is about, is trying to solve mysteries. There are things going on in the universe, and we're trying to understand how they function. And the universe is very clever. It doesn't make things obvious. Never makes it obvious. Just the simple thing of the Earth revolving around the sun. It's not obvious. You have to think about it. You've got to really look and study and understand deeply to figure these things out. And so that exploration started to get became the thing that really interested in me. I was originally in the movie business for 20 years because I was also interested in the art form itself. Unfortunately, I never made anything worth watching, and that's the bottom line. And when I really got sick of that, I decided, well, let me go back to space, because space is the ultimate exploration. While I was in the movie business, I was doing cave exploration, so I could go where no one has ever gone before. I've done that relatively, not routinely, but I have done it a number of times. And so when I decided to leave movies, I decided I was going to pick the field I wanted to write about. And so I decided to write about space and astronomy and science and focus on that. And this was in the mid-'90s. And so I started to write magazine articles, and then I said, I want to write a book. And the mission from the 60s that I thought was the historically most significant and actually had the most impact on the culture of the United States especially was the Apollo 8 mission to the moon. This was the mission that orbited the moon on Christmas Eve 1968. It was the first time human beings ever left Earth orbit. There will never be another first time of that, ever. And the first time humans traveled to another world. And I thought at the time in the 90s that this had gotten kind of forgotten in lieu of the landing, which my memories told me was important, but did not have the same impact. The impact came from the Apollo 8 mission. And so I decided I'm going to write a book about it. And so I proceeded to do so. And that book, Genesis, the Story of Apollo 8, it's available now in ebook, and it's doing really, really well, even as an ebook now, almost 20 years later, because I revised I didn't revise the book, but I added an afterword, and then the wife of one of the astronauts, Valerie Anders, wrote a preface herself to the new edition. But I wanted to write about that because there was things historically interesting about that mission and culturally important. And I also was curious, how the heck did they get around to actually picking to read from the first 12 verses of Genesis while they were in lunar orbit? And the story itself is quite interesting and fascinating, and so I wrote it. And so that's how I got into writing about space and astronomy and science and the history of space exploration. I'm interested in the idea of exploration. My website, Mike, is titled BehindTheBlack.com, and there's a reason it's called that. the term behind the black. If people go to the website itself and they look at the banner of the headline, of the website, you will see a picture from the Apollo missions of an astronaut with a rover on the moon, and there's this black sky. And to me, that's the symbol of exploration in every way, the human endeavor. There is a mystery out there behind that black, and we try to strive to figure out what it is. And it's what makes humans the most noble endeavor humans try to do.
Oh, I see.
So I hope that answers the question, but that's where I come from.
Oh, absolutely.
I like exploration.
Well, yeah. Well, I can't wait until more discoveries are made. Now, there are some people who, as you know, Bob, who believe that
I know where you go.
The moon landing never happened. Now, I'm not one of those people, but there are people out there who do believe that.
Well, all right. I'll give you the same spiel I've given on other shows when this Dan. Hello? Are you still there?
Oh, yeah, I'm here.
We had a bleep for a second, but I'll give you the same spiel I give every time. One, it astonishes me that there are Americans today that wish to denigrate one of the greatest achievements our country has ever made. They say more about themselves when they say that, try to discredit this achievement, than they do about the achievement itself. I know I've interviewed hundreds of astronauts. I've interviewed many of their wives and children. I've interviewed the wives of astronauts who have died, widows. I've talked to hundreds and hundreds of engineers who were involved in building the rockets and spacecraft that got us to the moon. There were 1 million people at Cape Kennedy watching the Saturn V launch. There were probably 100,000 companies involved across the country, employing millions of people building components for this mission. It was a great achievement to live so detached from reality that you think it didn't happen, and then, and in the process, to dishonor the memory of the people who were willing to die to make it happen is disgraceful to me. And I don't like to spend a lot of time discussing it, but I will say that right off the bat. People who do that are very low in my mind and very disgraceful.
Well, I think, yeah, and we won't spend a lot of time on it, but I think one of the big engines driving a lot of that is just all the conspiracy theories that people have put across the internet. I mean, really trying to muddy it up as best they can.
You know, Mike, I'll tell you something. This is a problem American society has right now in general. Our intellectual culture is very bankrupt. It is not based often on fact. There is a desire by too many people to see things that aren't real and to ignore things that are real. I mean, this is not space, but I just saw a news article about how the Obama administration is condemning Israel for terrorism in the last few weeks because Israelis have been killed by Palestinians. I mean, so wait a minute, hold it. What's reality here? Who's been getting killed? And so therefore, who's the terrorist? I mean, so we have this real warped intellectual culture right now that cannot see. It's like the emperor has no clothes in many cases, and we're focusing on these fantasy clothes that aren't there. So yes, there's a lot of conspiracy, but you know what? You go to the internet and you do searches, and you really have you're intellectually honest. You won't focus on this stuff. You will look for real facts, and you'll find the real. You'll find what we really know. We've really done. If you think that landing on the moon was a conspiracy, it means you've decided you want to make the United States look like crap. And your impression of the country is that we're all liars and dishonest and have no integrity, and we fake things and we don't achieve great things. And that is disgraceful, and it's a lie. It's a stupendous lie. And it shows incredible weakness of thought and intellectual capability to go that direction. And the same thing with the conspiracy things. The accusations that I've heard from truthers who say the U.S. government bombed the World Trade Center is despicable. Because it's even the slightest intellectual honesty will reveal that isn't true. And it's not much different from anti-Semitism and the same kind of dishonesty that that resulted in the Holocaust in World War II and millions of people dying. You've got to be intellectually honest, and that means you've got to be willing to look at facts very bluntly. And in the case of landing on the moon, it doesn't take much work to find out this happened. As I say, there were a million people watching the launch. You couldn't fake that very easily. And there wasn't just one launch. I remember I wrote about Apollo 8, which was orbiting the moon. That was not Apollo 11, and there was Apollo 10 in between that went to the moon and orbited the moon, and then there was 12 and 14 and 15, and there was also Apollo 13 and 16. So, it's just a joke. I don't really want to spend any more time. It's just disgraceful. I think that I'll just add one thing. Buzz Aldrin had the best answer to one of these fools who came up to him once after an appearance and said to him, "Wasn't that a fake?" And Buzz Aldrin's answer was to punch the guy in the face. And he was right. It's disgraceful. So if I've now offended half your audience and they're turning the radio off, I'm sorry. I can't help you.
Well, no, you're entitled to speak, whether it be your opinion or facts that provided. That's what we're here for. I mean, we're not here to, it's not about my opinion or anyone else's. You're the guest. I want to hear what you think. So,
okay.
So I appreciate that. And so, Bob, I thought maybe we could go into maybe some updates on the various space missions, namely Mars and Pluto. And even Jupiter. I guess they're going to get into the picture here real soon too. But water, blue skies, what's going on?
All right. Well, why don't we do this? Let's start and work our way out. How's that sound? We can do the whole solar system if you want, all the planets, including Pluto.
All right.
And so yes, Mars. Mars. We've got two working rovers on the surface. We've got a number of orbiters, not just us, but the Europeans too, and India as well has orbiters has an orbiter around Mars. And the amount of research and data we're pulling down from that planet has been pretty spectacular. And NASA has this thing about making big news press release things about the discovery of water on Mars. It is really remarkable to me how many times NASA has made a big deal about the discovery of water on Mars. We've known there is water on Mars since the teens of the previous century. It's not a big deal to say that we know water is on Mars. What has recently been interesting is the discovery that there might be flowing water on Mars. Not very much, but what happened is that Mars Reconnaissance Orbiter takes really spectacular pictures of the surface, and they monitor places on the surface. And back about a decade ago, when it first got there, it took photographs of what looked like dark streaks flowing down the sides of cliffs and crater walls. And these dark streaks were seasonal. They were not there. They would be very dark and vivid in the spring months, the thaw months. And then as Mars' 2-year-long year, the seasons changed, those dark streaks would fade, and then the next Martian year would roll around, and you'd see new dark streaks. And the theory had been, could this be groundwater seeping out of the surface and flowing down the hill? Well, now that's a theory, but in good science, you can't just go by theory. You've got to back it up with data. And so what recently happened 2 weeks ago, I posted this on the website, is that scientists did spectroscopy, and this is not easy to do from orbit because you're talking about very tiny objects. You need high-resolution spectroscopy, and it's almost more they don't have a rover at those spots, so they got to do it from orbit. It's hard. It's like it's really fuzzy imaging. But they did get spectroscopy, and the spectroscopy suggested that there are salts in these dark streaks. Now how does that mean water? Well, the theory was that the climate conditions on Mars are such that you can't have flowing water like we see on Earth. You need to somehow lower the melting point so that it can flow as liquid at a much lower temperature, below freezing. And your way to do that is you add salt to water. If you add salt to water, it can stay as a liquid at much colder temperatures. And there's a variety of salts. And salt in chemistry, salt refers to a large number of chemical combinations. And so the spectroscopy revealed that those dark streaks have a lot of salt in them. And so now from that data, scientists say this probably almost certainly confirms that the dark streaks are a salty water coming out of the underground, which has frozen ice below ground. And we see it flowing down the surface. Now, why is this so exciting? Well, if you can get flowing water, it means you have enough energy to produce a lot of different things, including possibly microbiology. So that's what made people very excited about that. There's lots of other stuff going on. In Gale Crater, you got the rover Curiosity traveling about, going up the hillside of Mount Sharp. That's the central peak of the crater. And scientists, this is once again a good example of scientists looking at Gale Crater from the images from the surface, have been pretty confident that it was likely once lake-filled. There was once a liquid lake filling that crater. That's why they picked that crater to land in, because they thought they'd find good evidence of liquid water in the past on Mars. And the idea was to have the rover climb the hillside up Mount Sharp, and as it does so, it's going to cross many different bedding planes, and you're traveling forward in time from very early Martian history up to the present as you go up those bedding planes. And this is now exactly what's happened. Just the same week, last week, they announced that the data they're getting as they're moving up the hillside is that they're getting close to the original water level, that below a certain point there is chemistry and geology suggestive of being underwater once in the past. You get clays, you get materials that would only form underwater. But now they're beginning to observe places above where the rover is at the moment, which don't have those kind of geological features, suggesting strongly that they're getting to the point where they're above what used to be the water table or the surface of the original lake. And that's really exciting because this just confirms previous data that suggests that the climate of Mars has changed significantly over time and was once a much more habitable place for life. So that's the Martian stuff. And then to conclude, Mike, on this is that I want to emphasize none of this proves there's life on Mars. And anyone who looks honestly at any pictures of any rover or lander that has been at Mars, you see an incredibly barren place. There is no obvious life. But the possibility that there might have been life, or that there might be vestiges of life, tiny microbiological life buried somewhere, this is possible, and this is what makes this really exciting.
What do you expect if we were to do a manned mission, and I mean people are actually able to go up there and really dig around and look? I mean, what would you expect to find?
Don't know. That's what makes science so exciting. It's exploration. I can make speculation, but what makes it exciting to me is we really don't know what we'll find. I mean, there is evidence, for example, Mars has these giant volcanoes. Well, they have the Olympus Mons, which is the biggest one, and then to the southeast of that is a line of three. And one of those three is a volcano called Osea Mons. And there are several things about the western flanks of Osea Mons that are really intriguing. One, there is evidence and photographs have been taken of cave entrances. Cave entrances are very useful for building a colony because they give you an interior space underground, protects you from radiation. You can enclose them very relatively easy. You don't have to build a structure so much as just create a balloon or a sealed environment. It's a place to go if you're going to build a colony. And secondly, there is strong geological evidence combined with meteorological evidence of water, frozen water underground on those western flanks. Orbiters over the decades, including Mars Reconnaissance Orbiter, as well as the Indian Mangalyaan Orbiter right now, have detected water vapor clouds seasonally over that western flank, suggesting there's a lot of water ice under the surface that periodically evaporates and produces water clouds. Not very thick, this is not like on Earth where you have rain, but still, it's water. And so that's intriguing. That's a place I would want us to go very much so, because not only is it potentially can teach us a great deal about the geology of Mars, its history, but gee whiz, we might be looking at a place that we could build colonies in. NASA's just released a 3-phase program for getting astronauts to Mars, but I don't pay much attention to what NASA does in these matters, and because it's always a show and lobbying for money from them.
Yeah.
What interests me about going to Mars is that I think we are still probably 3 decades of, maybe 2 to 3 decades away from being able to actually launch a mission to Mars to land. We conceivably could do a flyby or an orbital manned mission sometime in the next 2 decades, sometime in the next 10, 15 years, maybe. But landing on the planet is going to not be so simple. It's going to take time, and there's a lot of... I wrote a whole book, Leaving Earth, my second book. The whole book was really talking about how to build interplanetary spaceships and how we're going to get to Mars and other planets. And this is a technical, engineering, medical, biological problem that is very daunting, totally doable, but it's not something trivial, and it's going to take us time to learn how to do it. We, as yet, this moment, do not know how to build a spaceship that can keep people alive for these long journeys to another planet.
Well, and something else to consider, too, especially if you're the first astronauts to go, is how many failed missions have gone to Mars.
Well, let me clarify something about this. I've written about this at length. The number of failures to go to Mars, there have been a lot of failures, but the stats, just simply like that, distorts the reality. The United States has had almost no failures going to Mars. We've had 2 failures out of maybe 25 missions, maybe 30 missions. We have a stellar record. The Indians have sent 1 mission. It was a success. The Europeans have sent like half a dozen missions, maybe not many, maybe 4 missions, and they've had all but 1 fail. So why does it seem like 50% of the missions failed to go to Mars? Because during the Soviet era in Russia, they tried to send a lot of missions to Mars, and they had a 100% failure rate. So it's a distortion to think that going to Mars with the unmanned missions has this gigantic failure rate. No, what has a gigantic failure rate was the Soviet Union. And even after the fall of the Soviet Union, there was something really ironic. It was almost like they had a curse against the Red Planet. The Russians were cursed because on the one of the 2 American missions that failed, we had our first Russian science instrument. And it failed. And the one European mission that failed was using a Russian rocket. So they have, and I don't think this is just bad luck, and some of it's related to the Soviet Union and their quality control. But at the same time, the Soviets had a stupendously successful series of planetary probes landing on Venus, which is a much more difficult thing to do. So I can't explain that. Going to Mars is not going to be easy. Sending people to Mars is not going to be easy. It's a very challenging thing. It's probably one of the most challenging things humans will ever try to do in the future. But it's totally doable. It's just an engineering challenge. You have to figure out how to make it happen. building space stations really teaches us how to build those interplanetary ships, and that's and with the number of stations that have been built in the last half century, a great deal has been learned. And so if the focus is to build an interplanetary ship right now, I think there are a lot of aerospace engineers who would know how to do most of the work. There is just some issues that haven't been covered yet.
I see. Now, what about New Horizons probe?
Oh, you're jumping all the way out to the far planet. Let's talk about Jupiter first, all right? Let's work our way out. Not even Jupiter. Let's go to the asteroid belt. You've got Dawn right now orbiting the dwarf planet or largest asteroid in the system or planet, Ceres. And it sent back its first few it's orbiting the planet, and it's making a global map of that planet, asteroid, whatever you want to call it. And it's what it has that's really interesting is the surface is very bland. It looks almost like the moon, which is of course very, very different than the previous asteroid that Dawn looked at, Vesta, which looked like a broken planet, very weird, very cratered, very weirdly cratered. This one looks more like the moon. But among scattered on its surface are these really, really bright spots, which they think might be water, ice, lava. In other words, you might have volcanoes that pop the stuff up and then deposit it on the surface. Well, at least that was the first theory. But the data that they've gotten so far says, no, that's really not likely the case. And so you got this very bright material in the very small spots on the surface of Ceres, and they have really, at this moment in time, scientists really have no idea what they are. And Dawn is moving in a closer orbit over the next year, and we'll take higher resolution images, and hopefully we'll get some spectroscopy and have an answer to this question. But there's a mystery there. We have these really bright spots on this planet, on Ceres, and we really don't know what's causing them geologically. And so now we've gone out of the asteroid belt. Let's go to Jupiter. They just recently this week, using the Hubble Space Telescope, had released really cool images of the giant red spot on Jupiter and the various weather patterns and the banding on Jupiter and how it changes over time. And they have confirmed without question that the Great Red Spot continues to shrink. This is the biggest storm in the solar system. You could put multiple Earths within it, multiple Earths, but it's a single, giant hurricane. But it's much smaller than it was 100 years ago, and it continues to shrink. It shrank several percent in just the last 4 or 5 years. And the images they released were really cool, including very short, just a few seconds long movie, where you could see the clouds move, the bands move, and it's just really cool. And that's taken by Hubble in Earth orbit. This is one of the blessings of the Hubble Space Telescope. Then we can move to Saturn. I just posted something on Behind the Black. They released the Cassini mission's been there a decade. It's winding up. It'll have 2 years of study of Saturn, but it's finishing up its last flybys of the moons. They released a global map of Titan just recently, showing where they think most of the dark methane lakes are. They originally were able to study the southern hemisphere extensively. As the season has changed on Titan over the last decade, they're now getting a good look at the northern pole, where there's also lakes, and they issued a map of that. They're going to do some flybys of Enceladus in the next month or two, close flybys. That's the moon that has tiger stripes, they call them. They're vents on the south pole. And that south pole, those vents vent water. Once again, volcanic water. Water is lava. And so there's a thought there might be a liquid ocean under the surface of Enceladus. And they're going to do close flybys. They're going to do a flyby. They did a flyby today, Wednesday. They did a flyby today. They haven't released any data yet for it. They're going to do another flyby late in the month that's going to get as close as 30 miles, so they can get really good images of these tiger stripes. And they're trying to find out if this has a liquid ocean under the surface, because once again, you get a liquid ocean, you have the potential for life. Well, all right, so that's go ahead.
Well, I was going to say what I'm learning by a lot of this, and maybe I'm a little off or just jumping the gun, but it seems like water is plentiful.
Water, there's a lot of water in the solar system, but not. It's like gold, or at least valuable resource. It's not everywhere, but there is water available. You got to go hunt it out. It's like if we were going to go back to the moon and set up a colony. They were talking about doing it on the South Pole because they think there are those craters that are forever in shadow, and there's ice maybe at the base of those craters. So that would give you water on the moon, which would be an important resource. Not only can you drink it, but you can break it apart and get hydrogen and oxygen for fuel and oxygen to breathe. So it's a very valuable resource. So yes, there is water out there, lots of water. It's in different forms, but it's not everywhere, and you got to hunt it out. You got to find out where the likely places for it is. Back in the 60s, before any planetary missions went, no one would have ever dreamed there was water ice volcanoes on a moon of Saturn, active volcanoes, of spewing out water. That was never expected. Well, it might be there. So now we'll go farther. Let's go to Pluto, the farthest planet. And I use that term very intentionally. New Horizons flew past it in July. They released a few quick pictures right after the flyby, but then they had to spend a month doing a lot of engineering downloads because they had a plan for their next target deeper in the Kuiper Belt. They had a very limited time frame to get the path of the spacecraft changed so it could get to its next target. And they wanted to focus on that first. And so they've now been downloading data. And once again, what we find here is a strange and totally different place. In fact, both the Charon, the big moon of Pluto, one of its 5 moons, but the big one and Pluto, it's almost like a double system, those 2 moons. They're completely different from each other. Pluto and Charon are completely different. And it just proves something that I've said repeatedly in radio interviews and on my website. Every object in the solar system that we've gone to take a close look at, every single one of them has been entirely unique. They're always different from each other, and they show things that we did not expect. And what we did not expect to find when we got to Pluto is nitrogen glaciers, nitrogen flows, almost maybe liquid nitrogen flows, rivers, flowing around ice, which has the consistency of granite at those temperatures. So all the mountains are made of ice, but it's not like ice we know. It's really like granite. It's hard because it's so cold there. And this was not expected. And the pictures from Pluto have been just awe-inspiring because it's such an alien place. And it proves to me why the argument about defining a planet is premature at this point, because we know so little about what makes a planet up, and we're only now just beginning to get a taste of what planets are like. And to try to define what a planet is at this point is very premature.
And that's what inspires me, kind of, is that, NASA, often will say, well, this is what this planet is like, and then when they get close to it with one of their flybys, they find it's kind of different than what they expected. And so
it's very important to understand. I don't like to say NASA says this. There are scientists here doing this, and the scientists themselves have their theories and their ideas. And the good scientists will be very honest with you that they haven't the faintest idea, but this is a theory they have. And they want to go look. They're very excited to go look. They're as excited as I am to find out if their theory is right or wrong. And the good scientists, and most planetary scientists are really good scientists, are thrilled when they find out their theories are wrong. They're thrilled. They're excited. This is cool. This is great. The guy who's leading the New Horizons mission, Alan Stern, he had actually published a paper just prior, like the day before the flyby, in which he had posited the idea of maybe there'd be flowing nitrogen on the planet. So he was thrilled, pleased as punch, because his theory came out true. But there were other theories that were put forth. For example, Pluto has a very faint atmosphere, and the reason it has an atmosphere is because its orbit is somewhat eccentric, and when it comes in closer to the sun, the frozen nitrogen and other materials on its surface can start to evaporate and form an atmosphere. And this has been the theory, and Pluto did its close. Now, we've only known about Pluto for, what, like 90 years? Its orbit is 230 years long, so we haven't even seen and watched a full orbit of Pluto. And even in the first, the first 8+ decades of our observations were from Earth, and we really couldn't see very much. We've only got this, like, slight glimpse, one-day flyby. But in watching it, the theory had been that we'd see the atmosphere puff up during the close flyby, and then it would start to slowly settle again. And spectroscopy from Earth has not shown that puffed up atmosphere as expected, not to the degree that had been theorized. And what was most interesting when New Horizons flew by is the spectroscopy from the close flyby suddenly showed a lot more atmosphere than recent Earth observations had shown. All right, so now let's talk science. Is it suddenly puffed up in just by coincidence just before the spacecraft got there? The atmosphere finally just popped and we had became thicker. And this is, of course, not very thick. It's equivalent of almost a vacuum on Earth, but still thicker. Or maybe the Earth observations were wrong. Or maybe the New Horizons data isn't quite perfect. And that's the thing about science. In order to really get a clear idea here, they're going to they have a lot more data that's going to come down. It's going to give them a much clearer idea of what they saw when they did the flyby over the next few months, next year, actually. But right now, the planetary scientists studying the atmosphere of Pluto have a quandary. They can't quite figure out what the situation there is, and they are eagerly waiting further data from New Horizons to try to get an answer to that question. So science is a mystery, and it always is different the closer you look. I've written about this, Mars. Before we did our first flyby of Mars, we thought there might be canals and Martian civilizations there. The first flybys of Mars in the 60s happened to fly by the parts of the planet that have lots of craters. So after those first flybys, everyone concluded, scientists including, especially, that Mars was just like the moon. There was no life or anything of interest. And then we sent our orbiters there just a few years later, and discovered giant volcanoes, meandering stream beds, canyons, and found that no, Mars is not like the moon, it's not like the Earth, it's like Mars. And it's very strange, and even now, a half a century later, with many rovers and many orbiters and many landers, we are now just beginning to scratch the surface of understanding the geology of that planet. And it'll be centuries of discovery to look forward to.
So planets are kind of like people. I mean, you can't expect them all to be the same, right?
You absolutely shouldn't. And it's not just planets; it's asteroids. Every single asteroid was unique. So far we've gotten close looks right now at two comets, Halley's Comet and Comet 67P CG. And guess what? They look very different from each other. And the data we're getting from Rosetta, I haven't talked about Rosetta as I went out to New Horizons. How could I leave Rosetta out? Rosetta's been traveling beside Comet 67P CG since last August, as it's made its close approach to the sun and is now beginning to move away. And it's watched this strange cometary nucleus made up of two lobes, bigger and longer, that kind of got stuck together. And it's watched it get more active and produce more water ice off the surface. They've actually detected the surface changing with the surface evaporating away. They've seen jets come out of it. They've watched material settle back onto the surface. They put a lander on it. They bounced the lander on it several times, and they really haven't. They got some data from the lander before they lost contact. And it's a very weird place, and it really doesn't look much like Halley's Comet. The missions that took close-ups of Halley's Comet back in '76 saw a very different thing. It saw something almost like an asteroid, potato-shaped, irregular, not smooth, but it had a lot of activity, so much so that it was very hard to get a sharp image of the surface. Well, Comet 67P is not as active as that, and it has these two lobes that are stuck together. They're not sure how that happened. The recent data suggests that they were two objects that very gently collided and then stuck. There are others that say, no, that couldn't have happened. It's more likely they formed together. But this is, once again, science. We're puzzling over it. So every object is different. Every single object we've looked at looks different. The universe is a magnificent place because it's... Robert Heinlein said something, I think, really great in one of his science fiction books. He said, the universe is a mighty room for us to play in. And it really is the case. Everything you look at is different and unusual, and the variations thereof are so great. We have only begun to get our first glimpses of the universe. We're just beginning to get a sense of what's behind the black out there.
But we could find, do further missions and of course manned missions, I think, is important, but to some of these places, we could find that, a place like Mars, not only had water and lakes and stuff, but it actually had a livable atmosphere and all these things, and that there could actually, could there actually be, you know what I'm going to ask is because on Earth, we've had catastrophic things that have happened to this planet, and it seems like something always survives. Could something have survived?
Possibly, I don't know. That's the great question. You're hinting at some of the geological mysteries of Mars. To get liquid water on the surface of Mars, you must have an atmosphere that is thicker. They found flowing water, but we're talking about a minuscule amount. It's a seep. It's a very short seep, only 20 feet wide. The examples of these dark streaks, they're generally 20 feet wide and maybe a couple of 100 feet long at the largest. And they're not talking about a stream flowing down. You're talking about a seep, darkening the surface as it works its way downhill. So to get real liquid lakes, you need to have a thicker atmosphere. And the evidence from Curiosity strongly suggests that, yes, the atmosphere of Mars was thicker once. What was it made of? We really don't have a clear idea yet what it was made of. And so speculating about what Mars might have been like in its previous permutations as a planet is difficult at this point because we really, once again, have only scratched the surface of this geology. We don't know its full history. We only have a rough outline that scientists have put together based on the data they've got. But, they haven't done for example, they can't date things very well into the past. They date things by comet hits. The comets hit, and you can then, by the number of crater impacts. You date things by the number of crater impacts, and then you can figure out which things are older or younger by the number of impacts, because they know the rate of impact of meteorites or comets on the planets from the moon. So they have been able to kind of put a rough timeline on a lot of the geology on Mars, which came first, which came second, but actually date the events when they happened, they cannot do because they have never been able to do any good spectroscopy of chemical analysis of materials because they haven't had samples to work with. We're working from a distance, and even the rovers, even Curiosity, can do some chemical sampling and spectroscopy to get dates, carbon dating, but it's very limited what it can do. So we don't have a good timeline of the history of Mars and to understand the past. All things are possible. Whether there's life still on Mars, I tend to be very skeptical because I look at anyone who, you live on Earth. Can you go anywhere on Earth and not see life on the surface? You can't. The life is so pervasive on Earth that it changes the surface of the planet aggressively. Even underwater, you can't go anywhere without seeing life. It's everywhere. Even in the most remote places on the Arctic and the poles, there is life. Then you look at Mars, and it's barren. There is no life evident or visible. So I tend to be skeptical. There is the possibility of extremophile life, buried in those frozen underground water that they think is there. But we don't know that. And until we get there and look, we're not going to know. There is evidence of seasonally changing amounts of methane in the atmosphere of Mars in local locations. It's not planet-wide. It's only in specific areas. That suggests some kind of life form, because methane is not something that can last very long in an atmosphere. It breaks down very quickly. Plant life or animal life burps it out and produces it, but then it's very short-lived. So that suggests microbiology, but it's not known for a fact. And there are geological processes that don't involve life that can produce the same effect. So we just don't know. And what makes it cool from a science perspective and an exploration perspective, Mike, is that we don't know, and gee, it would be really nice to find out. So let's go and do it. That's what I like about this.
Me too. I just hope I live long enough to get those answers I've been seeking for so long. And I have a question here from the chat, and I'll periodically take those.
Sure.
Okay, we've got Michael, can you ask your guest if Jupiter is getting ready to ignite into a twin sun?
Absolutely not. Nope. Sorry, ain't going to happen. It's not big enough. It's not a very large. Compared to most stars, the mass of Jupiter is not very large. It's tiny. In fact, compared to even a red dwarf star, which is the smallest stars, Jupiter is significantly smaller. I do not remember the exact numbers, but we're talking about exponentially much smaller. Jupiter is large enough in mass that it generates its own internal heat from radioactivity. So that it actually emits more heat out than it gets from the sun. But we're not talking now about stellar processes producing, fusion reactions. We're just talking about radioactivity, uranium decaying, and that produces energy and that produces heat. But no, it is not even close. It's too small. It's not even a dwarf star, brown dwarf. Brown dwarfs are failed stars that have much more mass than Pluto, but far less mass than the smallest stars, and they have some nuclear processes that kind of have spurted and started, but never really took hold because they don't have enough mass to become a star. And so, no, Pluto is not. You don't have to worry. Jupiter is not going to explode into a secondary star. What Pluto is interesting is that it is very significant member of the solar system. It has more mass practically than all the other planets combined, and it influenced strongly how the solar system formed. And as they study exoplanets now and begin to get an idea of what other solar systems are like, they can then plug that data into our solar system, make comparisons, and maybe get a better idea of how our solar system formed. And Pluto was a significant component of that. For example, Pluto does a very good job of cleaning out asteroids, which makes within the solar system. It sweeps them up like a vacuum cleaner, and that's one of the reasons the Earth doesn't get bombarded quite as badly, or didn't get bombarded as badly in its past, because a lot of the once the Earth started to form and coalesce from the material in the disk that formed this whole system, a lot of the material that might have kept bombarding the Earth was swept up by Jupiter. And that gave the Earth some breathing room for life to start to form over the billions of years.
Isn't it amazing how everything has its purpose? It's like if you change just one thing, everything might be different.
Everything would be different. That's one of the things about, I mentioned, all the objects in the solar system are all different. The variables are so great that you see incredible variations from one planet to another. And of course, like on Earth, you get in close to the surfaces of these planets and asteroids, and you find incredible variation on the surface itself. The Curiosity images, I post them periodically on my website. It's like when you see a mountain from a distance, it just looks like this tall, flat wall peak. But as you get closer, canyons appear, and foothills appear, and details appear, and the details are endless. Well, Curiosity lands, and from above, Gale Crater with Mount Sharp in the center looks like a lunar crater in a sense, where you've got a crater rim, and you've got a central peak, and the flat floor of the crater. Well, as Curiosity has been working its way up the foothills of Mount Sharp, it isn't such a simple thing. It's incredibly detailed and complicated geology and topography. You could spend a lifetime as a hiker exploring it because it's so varied and interesting. And yes, so this is the wonder of the universe. It's really cool, and so we've just gotten a glimpse. We've just gotten our first glimpse. Realize the space age only started half a century ago, a little over half a century ago. The Hubble Space Telescope was the first optical telescope above the atmosphere. It's really the only optical telescope that's been above the atmosphere, and it's the only thing that's ever given us a sharp view of the universe, since ground-based telescopes have to look through this fuzzy atmosphere, and therefore they don't get sharp images. And so this is just the beginning. This is the beginning of the rest of the human race's life in terms of exploring the universe, and then the possibilities are just endless. They're just endless, and that's I think Carl Sagan was understating the thing when he would say billions and billions. It's infinity. The possibilities are endless.
Yeah, absolutely. Well, Bob, hang on with us for a moment. We've got
similar to us in any way, shape, or form. I'll use dolphins as a good example. It is very likely, based on the size of their brains and their ability to produce sounds, that dolphins do communicate with each other in a very sophisticated manner. And their ability to act intelligently in many circumstances suggests that they have a great deal of intelligence. But it's an intelligence that's very different from ours, and their methods of communication is very different from ours, and so different that we haven't really been able to establish communication, even though, we look at them and we think, yeah, they must be able to speak to each other in some manner. They're making all these really complicated sounds. And that's the species here on Earth that we have access to, we can look at. An alien species that forms on another planet, and we just spent the first hour of your show talking about how completely alien almost every object we've looked at has been. They're not just simply different from each other; they're also different from the Earth in incredible ways. For those planets or objects to produce alien life, it's not that it can't happen, but what if it does happen? The odds of that life being even close to similar to us in a way that we can comprehend each other is kind of challenging. Let's take it next step. Let's say there are aliens who built their spaceships and they're traveling and exploring the universe. That assumes immediately that they are similar to us in some ways. Well, if they are similar to us in those ways, then they're going to react to alien civilizations just like we will, which is that they're not going to keep it too secret. They're going to want to make contact and communicate. The Star Trek thing about the Prime Directive is all hogwash. When we find an alien civilization, we're going to want to learn as much from it as we can right off the bat, and vice versa, especially if they have any similarities to us at all. So now, is there aliens here on Earth? Well, if they are, they're doing a really good job of keeping it secret, and it seems to be implausible to me that they would do so. And we also have no real solid evidence yet of aliens, a presence on any planet in the solar system at this point.
Do you think, though, that they would be quick to tell us if they did find something like that? Because there are a certain fashion of people who... Yes,
I'm sorry to cut you off, Mike, but
That's
I mean,
okay.
if any scientific data came up that clearly showed some solid evidence of alien life or alien ruins or alien debris, that couldn't be kept secret a nanosecond, because every scientist on this planet, a planetary scientist especially, astronomer, that's like the golden, the pot at the end of the rainbow. I mean, just today I posted something on the web. The Kepler telescope that was in orbit looking at stars to see if it could detect transits across their face to detect exoplanets. Well, out of the 150,000 stars it has looked closely at, one star has a fluctuation pattern that cannot be explained. This was just a story, published paper this week, and there were news articles about it just today. And so the fluctuation patterns don't fit a solar system of exoplanets, crossing in front of the face. They have not been able to figure out how exoplanets could cause the brightness fluctuations that they've seen. And the brightness fluctuations don't match fluctuating star. So it suggests there's something around that star that's blocking its light periodically. And they tried to calculate what it could be to fit the fluctuations, and they have one theory, which is that another star had happened to fly by close and released a lot of comets, which had ascended to the inner solar system, and we just happened to be looking with Kepler when those comets happened to get close to the star and block its light. That's the one theory they've come up with so far. That's one theory they've come up with so far. The second theory, which they haven't published on yet, but the scientists say may be true, and they're going to do some further observations to try to see if it's true, is possibly we're looking at mega large artificially made structures around that star. And that's what's causing the light fluctuations. Now, they were very careful, because they're good scientists, they're very careful not to say that's what it is. What they're going to do is they're going to take a close look in the radio frequencies, because a technological society would produce certain radio frequencies, certain wavelength energies in excess of natural phenomenon. And maybe if they detect that, that would provide further evidence that maybe we're looking at a star with alien life. So I point this out because there's no secrets being kept. The scientists have a possibility, and boy, they want to reveal that, because that would make them world famous. That's the goal. They want to become, they want to make a discovery that will be remembered for eons of time. And so no, there'd be no secrets. There are no secrets going on here. The movie myth of Men in Black showing up to steal everything and put it into a hangar in Roswell, New Mexico, is absurd. It just wouldn't happen. There are just too many people involved who want to discover this and are not going to let it be secret. It's just not going to be.
Well, Bob, I could say this. Nobody could accuse me of only having guests on who share my theories and my ideas.
Yeah, I don't know what other stuff you guys talk about at other times, but I'm giving you my perspective, that's for sure.
Hey, we talk about it all, but I've heard it all. But it's good to talk to somebody who's really grounded and looks for solid evidence. It really is.
Always. No, yeah. I don't fiddle around. But I like solid evidence, but that doesn't mean I sit here and say, oh, it's not possible. We don't have any evidence, so there can't be. No, of course not. There could be life out there. And there could be life looking at us right now. Yes, that could be the case. A lot of your listeners dream and hope for that, and actually some of them, I'm sure, believe it. Well, that might be so, but I want to see the hard evidence. I'm not going to say, no, it can't be, but I'm going to want to see the hard evidence. Until I see some hard evidence, I'm going to be a skeptic. I will say this, that I also have, just this week NASA made a big deal about how they had released all the Apollo pictures, made them available on the web so that you can go through all the Apollo pictures if you want. Well, I've looked at all the Apollo pictures in writing my various history books. I was doing Genesis, story of Apollo 8. I went through. That's how I discovered who took the first Earthrise picture. Figured out the history of that on that mission, the very famous Earthrise picture, because I went through the entire set of pictures. Well, you do that. I would love to see a monolith in one of those pictures, but it's not there. So it's not there. I'm not going to make believe it's there. I'm going to be grounded in the facts here, because when we really do discover it, then it's cool, because we really have discovered it. When we good science is, not living in fantasy. You got to find what the truth is, and that's where I come from.
See, and I agree with that. I absolutely agree with that. Now, I was going to ask you about that distant star, because I was reading about that yesterday, and I read some more about it today. And they use the words alien structure. Of course, part of that is to pull people into the article, which it did.
Right.
But what exactly? I mean, do they think like it's satellites floating around this thing, or?
They don't know. They went down the list. The article, I initially didn't post it on my webpage because the initial articles I saw were being a little bit,
misleading.
Too much. They were pushing too much. They were saying things that just are ridiculous. But, okay, so let me quote from the article that I got from The Atlantic, which is, if another star has passed through the unusual star's system, it could have yanked a sea of comets inward. You know, this is a theory with our Oort cloud, why we sometimes have more comets than less. The theory that maybe, comet impacts causes mass extinctions. That's a theory. It's not proven by any means. But that's what they're suggesting here. Provided there were enough of these comets, they could have made the dimming pattern that they're seeing. But that would be an extraordinary coincidence. I'm still quoting. If that happened so recently, only a few millennia before humans developed the tech to loft a telescope into space, and that's a very narrow band of time, cosmically speaking, this is a really big coincidence to just happen to be looking at the moment when this sea of comets just happens to be on the inner solar system blocking the light of the star. Now, could it be other objects? It could be. Astronomy has some famous stars. I've written about them for Sky and Tel and Astronomy. One of them, and I'm blanking on the name of it. Every 24 years, it has it dims significantly, and astronomers have been baffled over what could be causing it to dim. It dims slowly getting dimmer, and then it's flat. The dimness is flat for a while, and then it slowly gets brighter again over a period of several years. And that suggests a very large object is moving in front of that star, but it's an object that has a fuzzy edge because it just doesn't get darker quickly. It takes time to do it. So the theory was there was a binary star orbiting the star, and Epsilon Auriga, I'm not pronouncing that right, I think it's the star, but they thought maybe there's a secondary star with a dust disk around it. Now, that's the theory that we've come up with now, but for decades, scientists hadn't the faintest idea. This is a strange place. I would not put it past the universe to come up with a completely natural phenomenon that produces these fluctuations, but we just don't know what that is yet because we're just beginning to look at these things.
Right.
Then again, until we have better data, the theory that it might be megastructures, a Dyson sphere or something similar variation, a ring world would be a more likely explanation. Well, until we have better data, you throw that theory in the pot and you don't dismiss it. And the scientists here aren't either. They're going to go and look more closely to see if they can detect any, radio waves. There was another study done recently, Mike. Scientists figured that if there were large galactic-wide civilizations, they would produce excess infrared energy. And so some scientists recently did a study looking at, they went down the list of catalog of galaxies that we've observed over the last, century, and they found about 200 that had excess infrared energy. And they went back and looked at them very closely because they said, well, gee, if we can't explain that excess infrared energy naturally, then maybe we're looking at a galactic-wide civilization. And they did that, and they came back and said, nope, as far as we can tell, almost every single one of those galaxies, the infrared excess could be explained by natural phenomenon when looked at closely. You'll notice, though, I did say almost every one of those galaxies. So who knows? They're looking closely. They want to find it. So this can't be kept secret. It's because everyone wants to find it, even the best scientists, and they're as excited by this as your audience is. No one's going to keep it a secret. It's going to come out there. And to think it's a secret is, once again, living in a fantasy world, especially a discovery that stupendous. It's not going to be kept secret. That's not going to happen. Even in a Soviet-style society that is tyrannical and doesn't believe in freedom of speech at all, it would be difficult to keep that secret. In a society like ours, which is still, to a certain extent, believes in freedom of speech, less so than it used to, but still so, it's kind of chaotic. You couldn't keep something like that secret. It's just not going to happen.
All right. Now, what about Hubble? You talked about it earlier, but is there something new on the way? Because as far as we can see, there's always further, isn't there?
Well, okay. One of my other books is called The Universe in a Mirror, and that's the saga of the Hubble Space Telescope and the visionaries who built it. I wrote the history on that, and the history of Hubble is quite a fascinating story in itself, because it's almost like Moses. Almost everyone involved in building that telescope was like Moses. They never crossed into the promised land. They conceived it, they designed it, they worked hard to get it built, but when it was finally launched, almost all of them were not involved in actually using it. And it's a really fascinating human interest story. And it's also a great story because, when I was growing up, before Hubble was launched, you got to get above the atmosphere to see the stars in the universe sharply. And the space age started in '57, and I wasn't even a 10 yet. We get into the '60s, we're going to the moon, still no optical telescope in space, but it's obvious we got to do it. And then the '70s roll around, and still no optical telescope in space. Why isn't it being done? Hubble was being built started to get built in '78. Then in the '80s, it's not being launched. The whole decade's passing. You have the Challenger accident, which delays its launch for 3 years. When they finally launch it in 1990, oh boy, we're going to finally see the universe sharp, and it's out of focus. So this was a long tale of woe, especially if you were growing up at the time like me, waiting. Kids today have it lucky. They see the universe sharply. I didn't see it sharply until 1993 when they fixed Hubble. And I was at the press conference when they announced that Hubble was fixed, and it was the most amazing thing I'd ever seen in my life to see some of those images. And I talk about the specific images that really blew scientists' minds up when they saw objects sharp for the first time. It has changed our view of the universe, and it's once again giving us our first glimpse of what's behind the blackout there. Now, in terms of Hubble was repaired. The final repair mission that took place in 2009 left the telescope in the best shape it was since launch. It has no instrument on board that was there when they launched it. They've replaced everything, several times over, and everything was state-of-the-art in 2009. And with multiple different cameras and spectrographs and other kinds of instruments to look at the universe in a variety of ways and wavelengths. Mostly optical, though, some ultraviolet and some infrared, but mostly optical. And the telescope, that repair mission in '09 was supposed to give them another 5 years. Well, it's 6 years later, and the telescope is doing better than expected. They have years, hopefully, of life left in it. It's in an orbit, especially because the sun has not been particularly active in the last decade. The atmosphere hasn't puffed up very much, which means that the orbit hasn't decayed very much. It has an orbit that will be solid and stable for at least another decade, maybe two. So thank goodness, because you asked me what's coming next. There is nothing coming next. Nothing still to this day is being planned. No optical space telescope is in the works by any nation at this moment in time. There are an increasing number of astronomers that have been proposing or lobbying for the building of another space telescope, but it is not happening, and I don't see it happening in the near future, unfortunately.
Okay, yeah, it'd be nice if we'd stop blowing so much money on war and we put that money into exploring, because one day we might actually need to get off this planet.
Yeah, in terms of optical telescopes, the story there is, I went into this a great deal of Universe in a Mirror, because in many ways it was the astronomers themselves that shot themselves in the foot. Because when Hubble was launched in 1990, in the 90s, astronomers, let me back up and just give some of the history. Astronomers on a decade basis, they produce something they call the decadal survey, which is that they survey the astronomy field and find out what the astronomers want built. And they released this report, and NASA has always taken it very seriously. So in the 90s, when they were getting ready to release the report that would come up in the early aughts, 2000, the initial plan was to talk about a next-generation Hubble, the next optical telescope. And during the political maneuvering to write that decadal survey, which came out in 2003, the cosmologists took over, and they convinced the astronomy community that they don't need a replacement of Hubble. Instead, they build an infrared, super-duper great infrared telescope to look deep, and look at the Big Bang. And that's what became the James Webb Telescope. whenever you hear a NASA news report or press release that says the James Webb is a replacement for Hubble, they are lying. I can't put it. I know I'm trying to be diplomatic here, but they are lying. The James Webb Telescope does not replace Hubble. It's an infrared telescope. It does not look in optical wavelengths. So it's going to produce images in infrared. It's going to do magnificent science, and it's focused on doing early cosmology, looking far back in time to try to understand the Big Bang. But it's not a replacement for Hubble. It's not going to be a general observatory in the same way, and it's not going to be an optical telescope. They decided to do that in the early 2000s, the astronomy community, and at the time they even said we don't even need to maintain Hubble aggressively. Once we get Webb launched, we can abandon it, which was absurd. And then the James Webb Telescope has been in the worst form of boondoggle. It was supposed to launch in 2011. It was supposed to cost $1 billion to build. We're now here in 2015. It's costing close to $9 billion to build, and it's not expected to launch until 2018 at the earliest. And the other aspect of the James Webb Telescope is, unlike Hubble, it is not designed to be maintained or repaired. It's going to be, because it's an infrared telescope, they're going to put it about 1 million miles away from Earth in the Earth's shadow to find a very, very cold spot, because to look at what is infrared light wavelengths but heat. And so if you want to get a clean image, you need to get as much outside heat sources away from all other heat sources as much as possible, so that when you look at the infrared from a star, you're only seeing the infrared from that star. You're not picking up anything from the Earth or from the sun. So they're going to put it 1 million miles from Earth in the Earth's shadow, where we can't get to it. And if anything goes wrong and it doesn't work, unlike Hubble, they will not be able to fix it. And so now that $8 billion has sucked the entire life out of the astronomy, astrophysics budget at NASA. There has been no money to build new missions in this decade. Astronomy hasn't seen maybe one astronomical telescope launched in the last 5 years, and there's nothing really in the works for the next 5 years. They just can't afford it. They've got to get this built first, because it's taking all the money out of them. It's actually stolen about $500 million from the Planetary program, which is a different line item. It's supposed to have its own independent budget. Well, it's science, and so NASA needed money for Webb, so they took some money from Planetary programs. So that means some planetary missions haven't launched that we'd hope to launch. But we have no optical telescope in the works. None is being planned. There have been proposals. Hubble hopefully can function for decades to come. You put an optical telescope in space, it always provides better data than anything on the ground. And Kepler is a good example of that. Kepler was an optical telescope, but it was a very small optical telescope. But it had such good resolution above the atmosphere that it could spot exoplanets by the thousands. On the ground, they can't do that. So that's where we stand in the optical world right now. Hubble continues to function. Keep your fingers crossed. Nothing goes wrong. Decades to come.
Well, I hope it continues to kick it. We've got Joe asks, could E.T. get here by extra-dimensional travel? Is it possible scientifically for something like that? I mean, does the math add up?
There are physicists who talk about things like multi-universes, and they do that because it can kind of help explain some of the subatomic physical phenomenon that they've observed. But when you get into that kind of area, you're beginning to get, to my mind, into the area of fantasy and science fiction, because we don't have a lot of data to back it up. It's mainly just theory. And so Joe is theorizing. He's not theorizing with as many facts as the physicists do when they come up with these multi-universes concepts. Uh-huh. And you know what? Their multi-universe concepts aren't proven or are not taken very seriously within the scientific community. They are looked at, and people don't dismiss them. But, that's nice. It doesn't mean anything really until you've got some data. So now he's asking me. Well, I'm not a nuclear physicist. And as you say, I like to be grounded in data. So that could be wormholes. Sure, maybe. Who knows? I'm not going to speculate on that. I think there's enough of really interesting things that we're learning on the cutting edge right now that I don't have to speculate fantasy on. I can focus on what's really cool. You know, I wait weekly for the new pictures coming down from New Horizons, because each week they post some more, and it's like, takes my breath away. Oh my God, what's that?
Yeah.
And that's on the surface of a planet, so I don't have to worry about multi-universes. I can get excited about discoveries in the real world.
Here's a good question from one of our listeners. Why have we never returned to the moon? And I bet you get that a lot.
I do get that a lot. I've written books on the reason why. Genesis Story of Apollo 8 actually touches upon it at great length. The Leaving Earth, the second book I wrote, touches at even greater length, because Genesis, once again available by ebook, if people want to get it, they can get it on my webpage or Amazon or any place like that, was mainly about the 60s space race, manned space exploration in the 60s, and why we went against the Soviets and why we wanted to do it and what our goals were. Leaving Earth was mostly post-Apollo manned history, and that meant there was a lot of Russian stuff, because that's stuff that was not covered in the United States, and I wanted to know about it, so I wrote a book about it. And there's a lot of interesting things the Russians did in the 70s, 80s, and 90s that most Americans don't know about, and it's really cool history stuff. But in writing Leaving Earth, I found that I was not just talking about the Russians, I was also talking about the Americans during the shuttle era. I found an interesting cultural phenomenon that took place in the United States. We decided, winning the space race, to prove that free enterprise, freedom, and capitalism and private property was the way to do things. But we used a government program to do it, which is Soviet style. And my generation, the 60s generation that grew up at that time, was thus convinced by our space victory that the Soviet way was the way to do things, because that's what a government top-down space program was, what the Soviets proposed, instead of a chaotic free enterprise, individual dream, private enterprise concept of the United States. So for the next 40 years, we had, quote, a space program, originally designed by government officials and politicians, mostly to feed pork into their congressional districts, and not really designed to accomplish very much or to take very many risks. And so the shuttle goes around the Earth a lot of times, but if you send it to build anything that's going to go beyond the Earth, that's risky. And we really just want to funnel money into our congressional districts. What is now happening now in the last decade, since I first wrote Genesis and proposed private enterprise as the way to do things, is you're beginning to see an influx of new private companies competing in the launch market. I write about this on Behind the Black all the time. SpaceX is the most famous. That's Elon Musk's company with its Falcon 9 rocket, but they're not the only ones. And what that competition and private enterprise is doing is it's creating a rebirth in that industry, which is going to not only lower the cost to get payloads into orbit, but make it profitable to put payloads into orbit of all kinds. And when that starts happening, when you can start making profit in space by launching payloads, it will become profitable to go to the moon, and we will go back to the moon very quickly. And I expect private enterprise to be back in the moon within a decade. I have no doubt about that at all. We're in that transition period right now. When George Bush canceled the shuttle program and Obama put the nail in the coffin in 2011, we didn't have a shuttle. We've now gone through almost 5 years without the ability of Americans to put our own astronauts in space. Well, sometime in the next 2 or 3 years, private company is going to be doing that, and we'll have more than one company doing it. And they'll do it in very different ways, which means we'll have variety and redundancy, and we'll have competition. And they'll be doing it for profit. So that meant that they can funnel the profit back into the company to do even more grander things. And all these companies are doing many, at least with SpaceX, especially Elon Musk. He's doing it because he wants to go to Mars. He wants to die on Mars. So he also knows he can't be unrealistic. The only way he's going to make that happen is he's got to make a profit. And so he's finding ways to launch rockets cheaper. And in December of this year, once again, SpaceX is going to do a commercial Falcon 9 launch of a satellite, communication satellite. Well, that doesn't sound very exciting, but they're going to try once again for the third time to vertically land the first stage on a barge in the ocean after launch so that they can save that first stage and reuse it. And this is truly, and I've seen the videos of the first two attempts. They're just fantastic to look at because, first of all, they hit the barge the first two times. That's amazing. They didn't quite nail it. They had crash, but they came very close. If they get that first stage reusable and landable, they will cut the cost of launch in half, even more so. And that's going to make it possible for a lot more people to put payloads in orbit. It's going to increase the customer base. Means more profit. Means more launch services. Maybe other companies can come along and make money on this, not just SpaceX. You start to see a very robust, chaotic industry of people, not a space program. Oh, I hate that. You get a chaotic, robust space industry of individuals and companies all following their dreams, making money at the same time. And the customers fulfilling their dreams by buying the products and getting up into space. And that's what is going to happen over the next few years. The reason, and so to answer the question, the reason we did not go back to the moon for the last 45 years is because we've been copying the Soviet Union and doing a Soviet-style, top-down government program, which is self-defeating and doesn't work.
I see. And, it'd be nice not to have to hitch a ride from Russia. And so speaking of that, one of the listeners asks, isn't Russia or China doing anything as far as missions to the moon or anywhere else for that matter?
Well, this is an interesting situation right now. Russia, after trying for 2.5 decades to do private enterprise, they just didn't get it. And so under Vladimir Putin, they just in the last year consolidated their entire aerospace industry into a single government-run corporation, kind of like the Soviet Union. And they're going to put together a 20-year plan for what they hope they will do in space, and they're going to organize it that way, and that's how they're going to do their space program in the future. I wish them luck. I think that's really a poor way to do things. It's probably going to get things organized initially, because there's always when you do that kind of thing, the initial push there's a lot of enthusiasm and determination, but it peters out in a government program very quickly. So I don't have much faith in that. The Chinese have been doing a Soviet-style program themselves, but they have been doing it in a very different kind of way, and they have a very robust space program with a long-term program plan, and that includes space stations and lunar landers and returning to the moon, bringing people to the moon sometime in the next decade or so. They are looking at their space station very deliberately. It is a prototype interplanetary spaceship that they're building it with that concept in mind so that they can learn the engineering on how to build interplanetary spaceships. This is what the Russians and the Soviets were initially doing with their Salyut and Mir station back in the 70s, 80s, and 90s. Trying to learn how to build a interplanetary spaceship. This is what my book Leaving Earth was all about. And the Chinese have the same attitude. They're copying Russian designs and upgrading those designs to build their space stations. They have a station up there. They've sent crews to it, I think, twice. They're going to have another crew go up to it next year. They're going to then launch a much bigger space station, which will be built modularly. You'll assemble it over a period of time, like Mir was assembled and like ISS assembled. But it's designed with the concept of being a prototype interplanetary spaceship. If you can keep people alive on it and maintain it effectively without a lot of help from Earth over a long period of time, that means if you added engines to it, you could have a crew on it and they could live on a flyby of Mars and come back to Earth. And that's a difficult engineering challenge, and they are focused on that right now. There's a government program. I don't have much faith in those kind of things. They tend to get corrupt and dry rot and lose focus over time. I much prefer the way the United States is going. In fact, it's a funny thing. The space race in the 60s, Kennedy proposed we go to the moon to prove that freedom and private enterprise and individual responsibility and capitalism was the best way to do things. But we used the Soviet system program, a government program, to win the race. And so we didn't actually have a race between communism and capitalism. We had a race between two different government programs, both socialist or communist in concept. Right now, we are actually finally seeing a true competition between capitalism and communism, or government and private enterprise, because the United States is transitioning to an entirely to a private enterprise system, private companies building, designing, conceiving, and competing for business, versus Russia and China going back to a government-run, top-down system. Both of them doing it. Both us and them doing it to try to get to space fast. So we're going to find out now which system is better. And if I had to put any money on it, I'm going to put a lot of money on the American way, the freedom and private enterprise.
All right. Well, Bob, we've got one last break we're going to take, and then we'll come back, and you and I will finish up. I've got a few more questions, and, of course, any questions from our chat room or phone calls, we'll take them. So, folks.
And I will tell you right off the bat, right now the science is very corrupted there.
Yeah.
Up to now, a lot of your listeners would think, oh, he thinks all those scientists are gods, and they would never lie to us. Well, there is, when politics gets involved and money gets involved, dishonesty comes up. And unfortunately, the climate field has been corrupted very, very, very badly. Back about a decade ago, I decided I'm really confused by this. I need to start to understand what's going on here. And so I really started to delve very, very deeply into it. I'm an unusual person. You might have heard of the IPCC. This is the Intergovernmental Climate Change Panel that the UN has, and they put out reports every few years. These reports range in like hundreds and hundreds of pages. I'm really unusual. I read them all. The 91, the 94 one, the 97 one, the 01 one, the 04 one, and then the 07 one. The one that just came out, I've read parts of it, but it was such a piece of trash, it's not really worth spending much time with. The climate field has been very, very badly corrupted. One of the things I learned in studying this field at great length, and I write about this on Behind the Black, my website, all the time, is the science is extremely uncertain. This doesn't mean that the climate isn't changing. This doesn't mean that I'm claiming that humans aren't causing the climate to warm. I'm not saying that. I'm not also saying that, no, humans have had no effect at all. No, I'm not saying that either. What I'm saying is that the amount of understanding here is extremely limited. We've only been studying the climate and our sun in sufficient, accurate detail and precision for 4 decades. Now, the climate is something that unfolds over not just centuries, but eons. And to understand how it functions, it's an extremely complicated thing, is not something that can be done lightly. It's hard. It's just like looking at those planets. We're looking at a difficult thing to study. So we don't really know what's going on. What we do know, there are facts we do know. We know, one, yes, the amount of carbon dioxide entering the atmosphere has been increasing to the last century, and it's probably almost certainly related to an increased use of fossil fuels, which burn off materials that produce carbon dioxide in the atmosphere. But we also know that carbon dioxide is a trace gas in the atmosphere. It is not the primary global warming chemical in the atmosphere. It has a very minor global warming component. Very, very, very minor. It's a trace gas. What really causes the atmosphere to warm is water vapor. And water vapor, actually, we have global warming and have had it now for millions and millions of years. Water vapor in our atmosphere probably heats the atmosphere about 20 degrees. Life would not be possible on Earth if the atmosphere was not wet, producing warming. It keeps us alive. It makes it possible for us to live because it warms the atmosphere. And water vapor is the main component of this. And this is something that took me a lot of digging to start to learn. The theories that humans are causing the climate to warm is based on a model, a theory, and that's a theory. Scientists have theories, even good scientists have theories, and sometimes those theories might be valid. The theory here is that the increased amount of carbon dioxide is going to interact with the water, and it's going to cause what they call a feedback, a series of feedbacks, that's going to force the water to produce more warming. It is never the carbon dioxide in the atmosphere that is producing the warming. There's not enough of it. It's always how the carbon dioxide affects other things to produce warming. That's the theory. The theory also stated that, and this is with the IPCC reports over the decades, that as the carbon dioxide increased, the temperature would increase in lockstep with it. Well, that's not been the case. We've had now almost 2 decades of no warming. The climate's been pretty stable since 1998. It had been warming pretty steadily, it appeared, from data, and then satellite data shows no warming for the last 20 years.
Well, Bob, why do they keep showing us polar bears grasping onto a beach ball size of ice in the water? They do that
because
for their
that looks so cuddly and cute, and you're going to want to cry, and they're going to make you. It's a crisis, and they never waste a good crisis. Make up a crisis if you have to get people to do things. I mean, I'm giving you some facts first. I mean, I hope that's not boring, but I'm trying to make it interesting, and I'm trying to make it clear. In terms of the data, the ground-based climate data is incredibly corrupted and not trustworthy in the slightest. I linked to a guy's website. This guy has a website, Steve Goddard, realscience.com, I think is the name of his website. He has been studying and comparing the raw data coming from surfaced weather stations versus the data that NASA and NOAA released to the public. And when you compare the two, it's astonishing how much is made up in the released data, not the raw data. And in every case, any adjustments the scientists at NOAA and NASA do to that surface weather data makes it look like the climate's been getting warmer. They always adjust past readings down to make it look colder and raise recent data up to make it look warmer so that it looks more like a steep hill going up. But if you look at the raw data, suddenly it flattens out. And there's a lot of this. Plus, there's clear evidence that one of the most important, the ClimateGate emails illustrated this really bluntly, but even before those came out, one of the most important scientists in the climate field is a guy by the name of Phil Jones. He's out in England at the Climate Research Unit. His papers, he had been the guy who had compiled all the surface data for decades, and he published almost all the papers on that. And all his, if you read science papers before 2005, you'll see him cited almost all the time, his papers on the overall trends of the climate based on surface data. Well, he admitted in around 2008 that none of the raw data from his papers is available. He lost it. But scientists don't do that. There had been good scientists who've been saying to them, look, we want to replicate your results. We want to see if your proof of warming is true. So can you please provide us the raw data so we can compare notes? And he was refusing to do it. People actually did freedom of information demands from him, and eventually he just admitted, well, I lost it. It doesn't exist anymore. It makes me very suspicious. And he was a major player in the ClimateGate emails, in which his emails indicate he was not honest. He was playing games to try to destroy careers of people who disagreed with him and trying to hide data. The famous line, hide the decline, is his words, because there is data in the last 2 decades suggesting either that the proxy data that says things are warming isn't good, or that things have been cooling down, and they wanted to hide that evidence, and they actually did try to hide that evidence. There is fraud that's going on in several of the papers and parts of the IPCC reports. So, in a long-winded way, Mike, to answer your question, yes, the data is very corrupt. Satellite data is the most reliable. It doesn't show warming for the last 20 years. Carbon dioxide is a trace gas. It's not the main player in this. We are adding carbon dioxide to the atmosphere. I will not deny that. I'm not trying to deny that. It is going to have a consequence. We're not sure what. Evidence so far suggests the consequence might be almost universally good, because guess what? Plants like carbon dioxide. And the plant life worldwide has actually shown increase in the last 2 decades, suggesting that they're thriving because of the carbon dioxide. Warming is maybe not a bad thing. We don't know if it's warming or not. This no warming for the last 2 decades might just be a burp, and we might see warming in the next few decades. There's reasons we won't. I'll get into that in a minute. But if things do warm, maybe that's good because that increases agricultural seasons. You can grow more crops. It makes more parts of the planet viable for growing plants, such as northern Russia and Canada. We have more food, maybe. So one of the things I always wondered about is this claim global warming is a terrible thing. I've seen very few studies to tell me how warming is really going to do us harm. It's generally just, we're all going to die, but that's not a study. That doesn't mean anything. Now, in terms of whether things are going to warm up, on my website on a monthly basis, I post the ongoing activity cycle monthly graph that NOAA publishes of the sunspot cycles, and there is circumstantial evidence that suggests that when the sun doesn't produce a lot of sunspots, the Earth cools. We do not know how they're connected. This is too difficult. We don't really have the data yet to understand how the cooling of the sun, which is not very much, can force the Earth to cool significantly. But in the 1600s, we went through a grand minimum, they called the Maunder minimum, in which for 70 years there were no sunspots. And during that period of time, that was called the Little Ice Age. We've had other weak solar maximums where very few sunspots have occurred. There have been sunspots, you haven't had none, but there have been few, and they always correspond with colder climates on Earth. And lo and behold, this most recent maximum going on right now is one of the weakest in 100 years. And the minimum before the maximum occurred in the last decade was long and extended, much longer than most solar minimums. So we had a long period with no sunspots. And lo and behold, we've had no warming for 2 decades and evidence of even some cooling in some areas. Once again, connecting the two is difficult because with satellite data we know that at least in this solar cycle, the sun hasn't dimmed that much to have caused that much cooling on Earth. So how does it work? There's some theories, and this is complicated, but when the sun isn't producing a lot of sunspots, the solar wind isn't as powerful. It allows more cosmic rays to get into the solar system and hit the atmosphere. If you've got more cosmic rays hitting the atmosphere, you produce more clouds, and maybe that's why it cools. That's a theory. It's not proven. There's data that suggests it might work, but it's just a theory. So anyway, the bottom line of this is that anyone who says to you the science is settled is, I'll be diplomatic again, a liar. The science is unsettled. It's very uncertain. It's good. Science is interesting when it's unsettled, when you don't know what's going on and there's uncertainties. They're trying to figure out the certainties. Going back to the IPCC reports, Mike, the first one in 1990 was really actually a very good report. It was basically the UN asked a bunch of scientists to assess the state of climate science, and they laid it out very well. If you want to understand the science of climate, you read that report because it lays out all the uncertainties, it lays out what they worry about, and they talk about what the consequences could be if various things happen, but they do not know, and they're not trying to push anything. None of the uncertainties of the 1990 report have been made any more certain in the subsequent 25 years. If you read the most recent IPCC report, they have not solved any of the uncertainties from the 1990 report. But they've decided to make believe things are more certain and to claim we're all going to die from global warming, and we therefore have to change all of our laws, give up all of our freedoms, all of our private property, and let some bureaucrat in the EPA in Washington, D.C. tell us how to live our lives so that there will not be more carbon dioxide in the atmosphere. That's really the heart of it. It's politics, it's power, it's trying to gain control over our lives. It has nothing to do with climate or the saving the earth.
It always is politics, isn't it? And so someone else asks about the weather and says, then they always blame climate change for all this weather phenomena. Well, if we can't link it to the so-called scientific data on climate change, then I've always thought that the sun has a lot to do with our weather, and could that be?
Yeah, the sun. The sun is the heart of the whole thing. It always is. To dismiss the sun is being foolish.
Yeah.
The amount of I've written about. If people go to Behind the Black and do a search for sunspots, they'll see a lot of the articles I've written on it, and they'll see a lot of data, not from me, but from other scientists, and they'll get a handle on that. The sun is a factor. It is a variable object. It does vary each solar cycle, but very small amount. Not enough to cause significant change in the climate. But scientists have never been, really modern science was never present during a grand minimum, where we have no sunspots for like 6-7 decades, a century. The last one was in the 1600s, just after Galileo used the telescope. We did not know then there even was a solar cycle, a sunspot cycle, because Galileo saw a few sunspots and then they disappeared for a century. And so that they wasn't even recognized as a normal phenomenon. It wasn't until the 1700s and 1800s that the solar cycle reappeared and we started to track it. So when a next grand minimum occurs, the next grand minimum, and it could be coming because of the sun's lack of activity in the last cycle, it's not known to be coming, but it could be coming, well, we will have an opportunity to finally study the consequences of such a thing and how the sun changes during such a phenomenon and how that affects the Earth, and that will be really wealthy knowledge. But we haven't had it yet, so we don't know, and that means the science is unsettled. We do not know. I will add one thing. You will hear quite often a lot of the global warming activist scientists talk about how 97% of the scientists agree that human-caused global warming is happening. That is based on one single study, which was 100% bogus. The guy who asked for information from like 10,000 scientists, but when he put his final paper together, he eliminated all but 77 of them. He happened to pick the 75 of which agreed with human-caused global warming. That's a bogus science paper, and it's a joke. And so the scientists in the field, I've talked to a lot of the good scientists in the field, and the first thing they'll tell you is if they're good scientists, they really don't know yet what's going on. They have theories. Some of them who believe in global warming, who are good scientists, will say, I believe that, yes, carbon dioxide is going to cause a feedback situation where we'll have more warming, and I'm trying to prove that. But if he's a good scientist, and I've known some, they say, but we don't know that for a fact yet, and we have to do more research to find out.
I see. Well, let me ask you this: what's next for you? What are you keeping your eye on? What's any appearances you've got coming up? Anything else that you'd like to get out there? By all means, go right ahead.
Well, I spend my time these days. The book industry has changed enormously. I have found that publishers, it's very difficult to get books published nowadays because of the internet and other things. Same thing with the magazine field. Instead, what I'm finding is the way to make my living is kind of like what you're doing, which is to publish my own webpage, make it available to people to read, and ask for donations. So Behind the Black is my main source right now. I recently, having nothing to do with space, because we moved to Tucson, southern Arizona, about 4 years ago, and I loved outdoor activities. I do cave exploration. I don't know if I mentioned that earlier. And I love to hike, my wife and I. So I put together a hiking guide for the southern Arizona area, and I'm actually going to do an appearance here in Tucson in about 2 weeks, talk about that. It has nothing to do with space at all, but it was fun because I wanted to do it. And it's like the whole industry's changed, so I self-published it because it was much quicker, faster. I didn't have to deal with editors who would try to change it for no reason. And I can get it published, and I can get it distributed myself very fast, and all the money comes back to me. So I'm doing that, and I'm doing my webpage. That's my main thing. I periodically do lots of different radio interviews. I'm a regular on the nationally syndicated John Batchelor show. I appear on that at least twice a week, talking about space and science stuff. And I am the official science advisor on Coast to Coast, your competitor. I have to say that. And so I appear periodically with them to tell them that a lot of the UFO stuff and alien stuff is hogwash, which is a lot of fun. But that's the way it goes. And I just and that's my focus. And Genesis Story of Apollo 8 is out. It's been very interesting. That was an ebook published by me after the hardbacks went out of print after. The hardback and the paperback were in print for almost, 22 years? But they finally went out of print about 5 years ago, and I regained full copyright control. And so I put out an ebook edition with a new forward and preface, and published it as an ebook, and have sold more ebooks than I had sold in the 5 years previously with the paperbacks. It's done very well. And if someone wants to understand something about what's going on today in space, they should read A Genesis Story of Apollo 8, because even though it talks about the 60s space race, it gives you the background and the context for why things... someone asks, why didn't we go to the moon? Well, that book will answer that question for you. You'll understand the historical context of what happened after the space race, why suddenly we couldn't go anymore. And why maybe now we're getting close to going again, and it won't be because of a government program. So that's what I do with my time, and I do book appearances with that periodically as well.
All right, well, fantastic, Bob. I keep up the great work, and we certainly support you over here, and I look forward to talking to you again in the near future, and thank you so much.
I would always be glad to come back, Mike, anytime. It's my pleasure.
All right, have a great night, my friend.
Take care.
All right, bye-bye.
Bye-bye.
All right, everybody, that is Bob Zimmerman, and he's linked.
Hello?
Good evening, Robert. This is Michael Vera with Late Night in the Midlands. How are you?
I'm just fine, Michael. You can call me Bob on the air.
All right.
In conversation, by the way.
That's great. I was just going to ask you if you'd rather I call you Robert or Bob. So, all right.
Well, when you introduce me, talk about things in print, Robert Zimmerman, but in conversation, Bob is fine.
All right. Well, thank you for pointing that out. And Bob, I welcome you to the show, and I'm looking really forward to kind of picking your brain about some of the things that are going on and what you know about them. So,
all right. Do you have a plan of action? We got a long interview, and what you want to talk about?
Yes, I do, and we're actually live now. So.
Oh, we are. Okay.
We are. So I'm ready to go, and. Well, I guess first, maybe a little background and what led your deep interest into space and beyond.
Well, all right. Well, first of all, I grew up in the 60s, and so, I was seeped in the original space race and the first efforts to get off of the surface of the Earth. And so that excited me as a kid. But as I matured, my interest matured to a wider concept of just interest in exploration in general. And that involves science, because a scientist, what they're really doing, if you understand what scientific method really is about, is trying to solve mysteries. There are things going on in the universe, and we're trying to understand how they function. And the universe is very clever. It doesn't make things obvious. Never makes it obvious. Just the simple thing of the Earth revolving around the sun, it's not obvious. You have to think about it. You've got to really look and study and understand deeply to figure these things out. And so that exploration started to get became the thing that really interested in me. I was originally in the movie business for 20 years because I was also interested in the art form itself. Unfortunately, I never made anything worth watching, and that's the bottom line. And when I really got sick of that, I decided, well, let me go back to space, because space is the ultimate exploration. While I was in the movie business, I was doing cave exploration, so I could go where no one has ever gone before. I've done that relatively, not routinely, but I have done it a number of times. And so when I decided to leave movies, I decided I was going to pick the field I wanted to write about. And so I decided to write about space and astronomy and science and focus on that. And this was in the mid-'90s. And so I started to write magazine articles, and then I said, I want to write a book. And the mission from the 60s that I thought was the historically most significant and actually had the most impact on the culture of the United States especially was the Apollo 8 mission to the moon. This was the mission that orbited the moon on Christmas Eve, 1968. It was the first time human beings ever left Earth orbit. There will never be another first time of that, ever. And the first time humans traveled to another world. And I had thought at the time in the 90s that this had gotten kind of forgotten in lieu of the landing, which my memories told me was important, but did not have the same impact. The impact came from the Apollo 8 mission. And so I decided I'm going to write a book about it. And so I proceeded to do so. And that book, Genesis, the Story of Apollo 8, it's available now in ebook, and it's doing really, really well, even as an ebook now, almost 20 years later, because I revised I didn't revise the book, but I added an afterword, and then the wife of one of the astronauts, Valerie Anders, wrote a preface herself to the new edition. But I wanted to write about that because there was things historically interesting about that mission and culturally important. And I also was curious, how the heck did they get around to actually picking to read from the first 12 verses of Genesis while they were in lunar orbit? And the story itself is quite interesting and fascinating. And so I wrote it. And so that's how I got into writing about space and astronomy and science and the history of space exploration. I'm interested in the idea of exploration. My website, Mike, is titled BehindTheBlack.com, and there's a reason it's called that. The term "behind the black." If people go to the website itself and they look at the banner of the headline, of the website, you will see a picture from the Apollo missions of an astronaut with a rover on the moon, and there's this black sky. And to me, that's the symbol of exploration in every way, the human endeavor. There is a mystery out there behind that black, and we try to strive to figure out what it is. And it's what makes humans the most noble endeavor humans try to do.
Oh, I see.
So I hope that answers the question, but that's where I come from.
Oh, absolutely.
I like exploration.
Well, yeah. Well, I can't wait until more discoveries are made. Now, there are some people who, as you know, Bob, who believe that
I know where you go.
The moon landing never happened. Now, I'm not one of those people, but there are people out there who do believe that.
Well, all right. I'll give you the same spiel I've given on other shows when this damn. Hello? Are you still there?
Oh, yeah, I'm here.
We had a bleep for a second, but I'll give you the same spiel I give every time. One, it astonishes me that there are Americans today that wish to denigrate one of the greatest achievements our country has ever made. They say more about themselves when they say that, try to discredit this achievement, than they do about the achievement itself. I know I've interviewed hundreds of astronauts. I've interviewed many of their wives and children. I've interviewed the wives of astronauts who have died, widows. I've talked to hundreds and hundreds of engineers who were involved in building the rockets and spacecraft that got us to the moon. There were 1 million people at Cape Kennedy watching the Saturn V launch. There were probably 100,000 companies involved across the country, employing millions of people building components for this mission. It was a great achievement to live so detached from reality that you think it didn't happen, and then, and in the process, to dishonor the memory of the people who were willing to die to make it happen is disgraceful to me. And I don't like to spend a lot of time discussing it, but I will say that right off the bat. People who do that are very low in my mind and very disgraceful.
Well, I think, and we won't spend a lot of time on it, but I think one of the big engines driving a lot of that is just all the conspiracy theories that people have put across the internet. I mean, really trying to muddy it up as best they can.
You know, Mike, I'll tell you something. This is a problem American society has right now in general. Our intellectual culture is very bankrupt. But yes, Mars, they've got we've got two working rovers on the surface. We've got a number of orbiters, not just us, but the Europeans too, and India as well has orbiters around, has an orbiter around Mars, and that, the amount of research and data we're pulling down from that planet has been pretty spectacular. And NASA has this thing about making big news press release things about the discovery of water on Mars. It is really remarkable to me how many times NASA has made a big deal about the discovery of water on Mars. We've known there is water on Mars since the teens of the previous century. It's not a big deal to say that we know water is on Mars. What has recently been interesting is the discovery that there might be flowing water on Mars. Not very much, but what happened is that Mars Reconnaissance Orbiter takes really spectacular pictures of the surface, and they monitor places on the surface. And back about a decade ago, when it first got there, it took photographs of what looked like dark streaks flowing down the sides of cliffs and crater walls. And these dark streaks were seasonal. They were not there. They would be very dark and vivid in the spring months, the thaw months. And then as Mars' 2-year long year, the seasons changed, those dark streaks would fade, and then the next Martian year would roll around, and you'd see new dark streaks. And the theory had been, could this be groundwater seeping out of the surface and flowing down the hill? Well, now that's a theory, but in good science, you can't just go by theory. You've got to back it up with data. And so what recently happened 2 weeks ago, I posted this on the website, is that scientists did spectroscopy, and this is not easy to do from orbit because you're talking about very tiny objects. You need high-resolution spectroscopy, and it's almost more than they don't have a rover at those spots, so they got to do it from orbit. It's hard. It's like it's really fuzzy imaging. But they did get spectroscopy, and the spectroscopy suggested that there are salts in these dark streaks. Now, how does that mean water? Well, the theory was that the climate conditions on Mars are such that you can't have flowing water like we see on Earth. You need to somehow lower the melting point so that it can flow as liquid at a much lower temperature, below freezing. And your way to do that is you add salt to water. If you add salt to water, it can stay as a liquid at much colder temperatures. And there's a variety of salts. In chemistry, salt refers to a large number of chemical combinations. And so the spectroscopy revealed that those dark streaks have a lot of salt in them. And so now from that data, scientists say that this probably almost certainly confirms that the dark streaks are a salty water coming out of the underground, which has frozen ice below ground. And we see it flowing down the surface. Now, why is this so exciting? Well, if you can get flowing water, it means you have enough energy to produce a lot of different things, including possibly microbiology. So that's what made people very excited about that. There's lots of other stuff going on. In Gale Crater, you got the rover Curiosity traveling about, going up the hillside of Mount Sharp. That's the central peak of the crater. And scientists, this is once again a good example of scientists looking at Gale Crater from the images from the surface, have been pretty confident that it was likely once lake-filled. There was once a liquid lake filling that crater. That's why they picked that crater to land in, because they thought they'd find good evidence of liquid water in the past on Mars. And the idea was to have the rover climb the hillside up Mount Sharp, and as it does so, it's going to cross many different bedding planes, and you're traveling forward in time from very early Martian history up to the present as you go up those bedding planes. And this is now exactly what's happened. Just the same week, last week, they announced that the data they're getting as they're moving up the hillside is that they're getting close to the original water level. That below a certain point, there is chemistry and geology suggestive of being underwater once in the past. You get clays, you get materials that would only form underwater. But now they're beginning to observe places above where the rover is at the moment, which don't have those kind of geological features, suggesting strongly that they're getting to the point where they're above what used to be the water table or the surface of the original lake. And that's really exciting because this just confirms previous data that suggests that the climate of Mars has changed significantly over time and was once a much more habitable place for life. So that's the Martian stuff. And then to conclude, Mike, on this is that I want to emphasize none of this proves there's life on Mars. And anyone who looks honestly at any pictures of any rover or lander that has been at Mars, you see an incredibly barren place. There is no obvious life. But the possibility that there might have been life or that there might be vestiges of life, tiny microbiological life buried somewhere, this is possible, and this is what makes this really exciting.
What do you expect if we were to do a manned mission, and I mean people are actually able to go up there and really dig around and look? I mean, what would you expect to find?
Don't know. That's what makes science so exciting. It's exploration. I can make speculation, but what makes it exciting to me is we really don't know what we'll find. I mean, there is evidence, for example, Mars has these giant volcanoes. Well, they have the Olympus Mons, which is the biggest one, and then to the southeast of that is a line of three. And one of those three is a volcano called Osea Mons. And there are several things about the western flanks of Osea Mons that are really intriguing. One, there is evidence and photographs have been taken of cave entrances. Cave entrances are very useful for building a colony because they give you an interior space underground, protects you from radiation. You can enclose them very relatively easy. You don't have to build a structure so much as just create a balloon or a sealed environment. It's a place to go if you're going to build a colony. And secondly, there is strong geological evidence combined with meteorological evidence of water, frozen water underground on those western flanks. Orbiters over the decades, including Mars Reconnaissance Orbiter, as well as the Indian Mangalyaan orbiter right now, have detected water vapor clouds seasonally over that western flank, suggesting there's a lot of water ice under the surface that periodically evaporates and produces water clouds. Not very thick, this is not like on Earth where you have rain, but still, it's water. And so that's intriguing. That's a place I would want us to go very much so, because not only is it potentially can teach us a great deal about the geology of Mars, its history, but gee whiz, we might be looking at a place that we could build colonies in. Is not based often on fact. There is a desire by too many people to see things that aren't real and to ignore things that are real. I mean, this is not space, but I just saw a news article about how the Obama administration is condemning Israel for terrorism in the last few weeks because Israelis have been killed by Palestinians. I mean, so wait a minute, hold it. What's reality here? Who's been getting killed? And so, therefore, who's the terrorist? I mean, so we have this real warped intellectual culture right now that cannot see. It's like the emperor has no clothes in many cases, and we're focusing on these fantasy clothes that aren't there. So yes, there's a lot of conspiracy, but you know what? You go to the internet and you do searches, and you really have you're intellectually honest. You won't focus on this stuff. You will look for real facts, and you'll find the real. You'll find what we really know. We've really done. If you think that landing on the moon was a conspiracy, it means you've decided you want to make the United States look like crap. and your impression of the country is that we're all liars and dishonest and have no integrity, and we fake things, and we don't achieve great things, and that is disgraceful, and it's a lie. It's a stupendous lie, and it shows incredible weakness of thought and intellectual capability to go that direction. And the same thing with the conspiracy things. The accusations that I've heard from truthers who say the U.S. government bombed the World Trade Center is despicable. Because even the slightest intellectual honesty will reveal that isn't true. And it's not much different from anti-Semitism and the same kind of dishonesty that resulted in the Holocaust in World War II, and millions of people die. You've got to be intellectually honest, and that means you've got to be willing to look at facts very bluntly. And in the case of landing on the moon, it doesn't take much work to find out this happened. As I say, there were a million people watching the launch. You couldn't fake that very easily. And there wasn't just one launch. I remember I wrote about Apollo 8, which was orbiting the moon. That was not Apollo 11, and there was Apollo 10 in between that went to the moon and orbited the moon, and then there was 12 and 14 and 15, and there was also Apollo 13 and 16. So, it's just a joke. I don't really want to spend any more time. It's just disgraceful. I think that I'll just add one thing. Buzz Aldrin had the best answer to one of these fools who came up to him once after an appearance and said to him, "Wasn't that a fake?" And Buzz Aldrin's answer was to punch the guy in the face. And he was right. It's disgraceful. So if I've now offended half your audience and they're turning the radio off, I'm sorry. I can't help you.
Well, no, you're entitled to speak, whether it be your opinion or facts that provided. That's what we're here for. I mean, we're not here to, it's not about my opinion or anyone else's. You're the guest. I want to hear what you think. So,
okay.
So I appreciate that. And so, Bob, I thought maybe we could go into maybe some updates on the various space missions, namely Mars and Pluto. And even Jupiter. I guess they're going to get into the picture here real soon too. But water, blue skies, what's going on?
All right. Well, why don't we do this? Let's start and work our way out. How's that sound?
All right.
Do the whole solar system if you want, all the planets, including Pluto.
All right.
And so